Hi everybody, in this video we are going to talk about basic laws, and our first law is Ohm's law. In chapter 1 we are introduced to basic concepts such as current, voltage, power, but to be able to calculate them we must know some basic laws, and the first one is Ohm's law. Materials in general tend to resist against the flow of electrical charge, and this tendance is called resistance. Actually, resistance is the ability to resist against the flow. Resistance is denoted by a capital R. Let me write it in here, and the unit of resistance is ohms. Ohms is denoted by this symbol. The resistance of any material with a uniform cross-sectional area A and the length L. Let me write it in here. A is the cross-sectional area and L is the length. In that case, the resistance of any material will be R is equal to P times L over A. Let me draw a material in here just for clarification. Let's say we have this kind of material and it has a cross-sectional area A in here, and let's say the length is L. The formula for resistance of this material is P times L over A, where this L is the length. This A is the cross-sectional area. What about this P? This P is known as resistivity. And actually, resistivity is unique for each material. So each material has different resistivities. Good conductors such as copper or aluminum have low resistivities. However, insulators like paper have high resistivities. That's an important point. The resisting behavior of any material is shown with a resistor in our circuits. So when we want to show the resisting behavior of a material, we use resistors in our circuits. The symbol of a resistor is this one. This is a resistor in electric circuits. Resistors are generally made of metallic alloys and carbon compounds, but it's just an additional information. So far, we have seen the resisting behavior of material and the formula for resistance. We see the unit of resistance, we see the symbol of resistors in the circuit. Now it is time to explain what is Ohm's law. Ohm's law is actually stating a situation that is related to resistors. That's why we explained the details of resistors first. So Ohm's law actually states that voltage across a resistor is directly proportional to current flowing through the resistor. Ohm's law is saying that if you have a resistor in here, and that resistor has a voltage across its terminals and also has a current flowing through them. So Ohm's law states that this voltage and current is directly proportional to each other. So if you increase the voltage across the resistor, then the current flowing through the resistor will increase too. So Ohm's law states that they are proportional to each other. So what about the ratio? How can we know the ratio? Actually, the ratio is resistance. The constant of this equation is defined a resistance by Ohm's law. In that case, Ohm's law will be V is equal to I times R. So the ratio is R in here, and that's the Ohm's law. Basically, Ohm's law states that current flows through a resistor and the voltage across a resistor are directly proportional to each other, and the ratio is resistance. That's the Ohm's law. This formula is really important. In here, we have two circuits. As you can see, one of them is a short circuit and the other one is an open circuit. You don't know yet what is a short circuit or open circuit. An element with zero resistance is called a short circuit. So in here, there is no resistance through this path. So this is a short circuit. If resistance value is zero, what about our Ohm's law? Our Ohm's law is V is equal to I times R, where I is current, R is resistance. If resistance is 0, our voltage value will be 0 too. So we have just proved that if we have a short circuit, the voltage across the circuit, the short circuit, must be 0. However, current could be anything because we don't know the value of the current. This is an important note. If we have a short circuit, let me just write it again in here. The resistance of circuit must be 0 and the voltage across the short circuit is 0. This is for short circuit. In here we have another circuit, but this time our resistance value is not 0, however it is infinity. So think about it. If our resistance value is infinity, our formula for Ohm's law is V is equal to I times R. If we rearrange the terms a little bit, we will have V over R is equal to I. So when we put R is equal to infinity, it is clear to see that our value for current is going to be 0. As you can see here, there is a disconnection. Therefore, our current cannot be any number but 0. In open circuits, we have two rules. Let me write it in here. Open circuits. The rule number 1 is our resistance value is infinity, and the second rule is our current value flowing through the open circuit is 0, but voltage value can be anything since we don't know it. Let me move on. Other than that, we have different kinds of resistors. A resistor can be fixed or variable. Most of the resistors are fixed in our circuits. The circuit symbol in here that I showed you before is used for fixed resistors. If you see this kind of symbol, let me just draw it in here. If you see this kind of symbol, that means this resistor is variable. So what is the difference? The fixed resistor has only one resistance, it just doesn't change, it is constant. But in a variable resistor, its resistance value may change. We also have another symbol in circuits, and this is neither a fixed resistor or variable resistor. This is called potentiometer, or you can say pot briefly, and I'm gonna use that one. In pots, by sliding the wiper, the resistance between the wiper and the fixed terminals change, and that's the logic of pots. But we will talk about pots later. We have seen three kinds of resistors. One of them is fixed resistor, the other one is variable resistor, and the last one is pot. However, it should be noted that not all resistors obey Ohm's law. A resistor that obeys Ohm's law is called a linear resistor. So in here we have two graphs, and this graph belongs to a linear resistor. However, this one belongs to a nonlinear resistor. If a resistor obeys the Ohm's law, it is called linear resistor. If the resistor doesn't obey the Ohm's law, that's going to be called nonlinear resistors, and that's the only difference between a linear and nonlinear resistor. And as you can see here, the slope of curve doesn't change in graph 1, so we can say that this is a graph of a linear resistor. However, in the second one, in the number 2, the slope of curve change time to time, which means this graph belongs to a nonlinear resistor, which means this resistor doesn't obey the Ohm's law. Just keep in mind that light bulbs and diodes are great examples for devices with nonlinear resistance. That was all for resistor and resistance and Ohm's law with resistors concept. Now I'm gonna show you another useful quantity in circuit analysis, which is conductance. Let me write it in here. The conductance is a measure of how well an element will conduct electric current, and the unit is mho. Notice that this is ohm backwards. So remember that resistance was the ability to resist against the flow. However, conductance is measuring how well you are conducting the electric current. Therefore, it is safe to say conductance is the opposite of resistance. Additionally to these informations, conductance also has another unit called Siemens. And also conductance is denoted by G. So we can actually say G is equal to 1 over R. Simply, conductance is the opposite of resistance, but sometimes it might be simpler to use conductance instead of resistors. For that cases, we need to know about conductance. So when we think about the Ohm's law, we know the Ohm's law is equal to voltage is equal to current times resistance. And we know that resistance is equal to 1 over conductance. If we replace our R or our resistance with 1 over G, we will have V is equal to I over G. So if we just take this G to the other side of the equation, we will have V times G is equal to I. And now we have another formula for Ohm's law if we are going to use it with conductance. Now let's have a look at how can we express the power absorbed by a resistor in different ways. So we know that power absorbed in a resistor is actually equal to voltage times current. And we also know that voltage is equal to current times resistance. So if we just replace each voltage value by I times R, we're going to have power is equal to I squared times R. And that's the first equation that we derived from two equations. We can also rearrange the terms a little bit in Ohm's law and say I is equal to V over R. So in that case, if we replace each I by V over R, then we will have P is equal to V squared over R. And that's the second equation we derived from these two equations. We can say actually we have three different formulas for power. Let me write it in here. Power is equal to V times I, and also V squared over R, and also I squared times R. We can use these formulas just in case we might need this information. What about if we do that by using conductance values? We know that power is equal to voltage times current, and we also know the Ohm's law for conductance values, which is V times G is equal to I. If we replace each I by V times G, voltage times conductance, we will have power is equal to V squared times G, and that's the first formula that we derived from these two formulas. And also we can rearrange the terms a little bit in Ohm's law in here, so we can say voltage is equal to I over G. And when we replace voltage in our power equation by I over G, we will have power is equal to I squared over G. And that's the second equation we have for power when we are calculating it with conductance. So we can say power is equal to V times I, which is going to be equal to I squared over G is equal to V squared times G. And that's the formula for power measurement by using conductance. And that's the end of the lesson, but I have few notes that I like to mention about. The first one is the power dissipated in a resistor is a non-linear function of either voltage or current. This note means that the power dissipated can be a function of voltage or function of current. It doesn't matter. but it is not a linear function. It is a nonlinear function since your voltage and current values can change from time to time. That's the message in here. The second note that I like to mention in this lesson is since our resistance and conductance values are positive, because they are constant, they cannot be negative. You cannot say, yeah, I have -5 resistance, I have minus 10 ohms in my hand. That's just not possible. So resistors always absorbs the energy. They're passive elements. They cannot generate energy. That's an really important point. Resistors are passive elements, so they cannot generate energy. Therefore, they have to absorb the energy. That's the second note. So let me write it in here. And that's the end of the lesson, and that's the end of the video. There will be more videos that I will solve some problems about this topic later. For now, this is it. Thank you.